Hello, I'm Fiona Waters, and I'm a 24-year-old geospatial scientist specialising in climate change. I'm from the UK, and I'd say my experience includes climate change impacts, hazard mapping, and environmental modelling, which I've gathered through academia, private, and public sector work. One thing that's quite unusual about me maybe is that I actually did not study geography GCSE, but then took a Open University module after my GCSEs on the frozen planet, which I just found fascinating. I think it was partly inspired by the David Attenborough's The Frozen Planet, which was running at the time, but it inspired me to reconsider and take geography back up for A-level, which was clearly the right decision, as I then went on to study physical geography at Bristol University. Although I definitely was most interested in future climates at university, I'm in my undergraduate university. After, I did spend a couple of years trying out various aspects of environmental work in consultancies, charities, communication, and these were both paid and unpaid experiences. I also signed up to lots of talks, events, and webinars in areas which interested me, and I set up my own sustainability blog, which gave me a bit of a purpose and a way of documenting the talks I was going to, but also widened my network and helped me to confirm that the area which I was most interested in was indeed climate change. I therefore started a master's in London in 2019, and it was so great to be surrounded by so many like-minded people, all with the same purpose, only to have it moved totally remote due to the pandemic. During this time, I also did an internship at the Zoological Society of London, exploring the impact of climate change on the Amazon rainforest and vice versa. So the relationship, which I personally just found truly fascinating and such a worthwhile experience. I also became a fellow of the Zoological Society of London and the Royal Geographical Society, both of which hosted talks and events which I found useful to try and gather starting points for my dissertation topic. Following this, I'm currently working as a geospatial analyst and climate change scientist for the Shaw Consulting community as a sole trader, which is essentially kind of a bit of a freelance style of work. Shaw is a group of like-minded environmentalists working in a transparent, collaborative, and in an innovative way. Everything is totally remote and would be without the pandemic, so it means it's very flexible and perfect for my current lifestyle because I can pick and choose my hours a bit. I found, looking back on my experience, that really creating my niche and being proactive, reaching out, and independent learning has really put me in the best position to do the purposeful work which I enjoy. So my why. I am a huge nature lover. I'm so passionate about living in harmony with this planet rather than against it. And I just feel that as our impact as humans is becoming more and more pronounced on the planet, it's just so much more important than ever to conserve the planet for future generations as well as ourselves, as it's essential for life on Earth. And so no one can say it better than the words of David Attenborough. Never before have we had such an awareness of what we are doing to the planet, and never before have we had the power to do something about that. Surely we all have a responsibility to care for our blue planet. And that is my why. And geoscience is the way forward with that. So just a bit about what geosciences can give back to you. Geosciences, I believe, leads to such diverse skill sets. The teaching structure tends to be very varied with the combinations of lectures, seminars, fieldwork, lab work, and computer skills. We had a fantastic field trip to Arolla in the Swiss Alps during my undergraduate degree, which was investigating the water composition in chemistry, but we also managed to take in some amazing snowy views, and it was very sociable. This leads to all-rounded life skills, for example, in writing, presenting, and project development, which are so transferable into many realms of work. And here is just an example of some of the modules which I took throughout my further education. Geosciences are such a vast field. Everything happens somewhere, everything has a geographical location, and therefore it is part of geography. So it's so broad. Particularly in the current climate, I just believe it's such a relevant and valuable field to be part of. I would classify my current expertise into 4 categories. geography, climate change, geographic information systems, or also GIS, and data science. I'm still young and I do still have a lot of experience ahead of me. However, my aim of this presentation is to highlight to you just how diverse a career in geoscience can be. So to start with, my master's dissertation, I tailored my master's degree to the topics of climate change, which I found most interested me, which was usually the impact and relationship of climate change with the tropical forest ecosystem. With such a large above ground biomass carbon store, they are hugely important consideration for climate change mitigation, particularly the Congo Basin, which is the one that I studied. Per area, the Congo Basin forest has a higher carbon density than the Amazon and the Southeast Asian tropical forests, which means it's hugely important for climate change mitigation, and elephants have been attributed to be potentially part of the cause of this, as they clear the undergrowth, leaving more space and light for the trees to grow bigger and store more carbon. Sorry. So my study explored the relationship between elephant habitat ranges and forest carbon stock of the Congo Basin rainforest through a spatial multivariate regression analysis of remotely sensed carbon stock data, alongside other hypothesized variables, including climatic, topographical, and anthropogenic. The links between wildlife and ecosystems truly fascinate me, particularly in relation to climate change. However small each species, they all play a unique part in the working and the functioning of the ecosystems. So this is an example of a project that I took part in with Shaw Consulting for the Asian Development Bank. It was looking at environmental risks for a selection of project locations and how future climate change could exacerbate those risks. To the left, we have an example location of a municipality in the east of Georgia, which is likely to experience a significant increase in temperature and slight increase in extreme rain events by 2050, as the maps to the right show. Therefore, in order to enable for the developments to be sustainable, they should accommodate for these future predictions, which could increase the likelihood of wildfires, droughts, and potential flood risk. As I mentioned before, whilst I was gathering experience and finding my interest within geography, I started my own personal blog to document the talks I was attending and the information I was learning from them. From this, I was then asked to become a writer for this amazing platform, She Sapiens, which aims to empower women to spread positive action. I contribute a monthly article for them on any aspect of climate change that I wish to choose. And for me, this is great for my personal development because it encourages me to continue to read around the topic. However, perhaps my more day-to-day work of the moment lies with utilising GIS, so Geographic Information Systems. GIS is essentially a means of representing data based on its location in a very visual form. A more technical definition is that GIS is a computer system capable of assembling, storing, manipulating, and displaying geographically referenced information. GIS data comes in two main formats: raster data, such as the layers portrayed here, this is the slope layer, which you see on the screen now. And this has been derived from satellite elevation data. The steeper slope is represented by the red colouring and the gentler slope by the green. These raster datasets have been used within calculations to identify, for example, the sinkhole locations, as was just on your screen there. Vector data is the other type of data, which includes points, lines, and polygons. So the polygons of the sinkholes can be seen on the screen there. And polygons representing the catchments are just about to emerge now. There we are. So the polygons of the catchments here have then been categorized based on the number of sinkholes which are present within each of them. This highlights the flashy catchments and the ones which are then at greater risk of flooding downstream as the water runs through the lava tubes, through the sinkholes, and out at the base of the catchment. This wealth of geospatial data enables features and hazards to be identified, which are, for example, potential flood risk hazard zones. A slight side project that I've kind of started for myself recently is myself and another colleague at Shaw spotted the potential of beautiful visuals using geospatial datasets, and we've decided to start a small artistic side project. My aim for these maps is to highlight the beauty and the shape of the natural landscape to contribute towards the importance of preserving it. The geospatially referenced data layers can be analysed and input into calculations to highlight certain characteristics. Such calculations include machine learning. Machine learning and data science are emerging fields within environmental science. Machine learning, in essence, refers to training computers to recognise patterns in data, for example, through classifying and clustering to then make predictions. So here we have the slope, symbolised by darker brown for a steeper slope. However, on the right, we have the output of a various selection of derivatives from the elevation satellite data, which have been run through a clustering algorithm to highlight regions of similar landscape characteristics. There are various online free courses available for machine learning. I actually self-taught myself through some of these, although some of it may be familiar through maths at school, or I also learned a little bit through both of my geography university courses. So here, another clustering algorithm has been run to pick out potential areas of fluvial hazard based on the geomorphology. The Shore community is a very unique setup. We all work independently within our own hours and remotely, even without a pandemic. This is ideal for me because it means I can choose my working day and incorporate in the dog walk, exercise outdoors, and getting out into nature, which is ideal for flexibility. This is a brief video to explain the work style of the Shore community. Shore essentially offers GIS and environmental expertise. The project-based environment is varied, each project is slightly different, and you are consistently learning on the job, which is something I really enjoy. The team covers a range of expertise, so you learn from others in a community approach, whilst also developing your own niche and expertise, which others then come to you for. I like to think of it as the projects are worked on by a few individuals, but supported by the whole community. Using a combination of scientific expertise and GIS skills, Shore provides visual, tailor-made product deliverables. Client satisfaction and relation are key, and their relaxed atmosphere, everyone is treated equally, and it's such a great flexible working environment. To finish, I think that finding your why is something which is so important for work. I enjoy feeling like my work is purposeful and feel like I'm having a positive influence towards sustaining the natural world. Your why will change and evolve, and I most definitely did not know what I wanted to do before university. I chose geography because it kept my options open and offered a range of potential skill sets. Through webinars, talks, and extra reading, I refined my interests, kept good relationships with those I met, and took work experience to develop certain skills. Starting out into your ideal job is very rare. However, I'm a big believer of shaping your skill set to put you in the best position you can for your ideal role. Thank you.